Array processing can be used on appropriate DNB line arrays. To use array processing effectively, the venue data and pick point locations must be precise, or the simulation and optimization process will not be accurate. Calibrated inclinometers on flying frames are mandatory, and dual pick points recommended to control the vertical tilt of the array on site. Having finalized a detailed and precise venue and array design, enable the array processing function within the array widget. As soon as the array processing function is enabled, changes in venue data and individual cabinet settings are locked. Grouped functions like configuration switches and delay are still available. As soon as array processing is activated, the minimum delay of the respective channels is 6.2 milliseconds in total. Array processing uses individual filter settings for every single box in an array. Every channel of the latest generation of DNB amplifiers has 9 user-definable slots for different filter settings. When optimizing the array during simulation, first choose a slot number. Then press Process, which will open the configuration window. Electroacoustic adjustments can now be set in the first tab. The level over distance can be defined in 3 variable slope zones. 2 markers define the transition between zones. Within each zone, the level drop per doubling of distance can be adjusted separately. Individual listening planes can also be offset in level, for example a stand that has not been sold. For the correct compensation of air absorption, environmental conditions can be specified in temperature and humidity. Finally, the processing emphasis can be set using the power or glory fader. The default setting of 0 will give a good balance of all parameters. If headroom is not the highest priority, the glory setting means that peak output might be sacrificed by the algorithm to achieve a more broadband tonal balance control. If, on the other hand, maximum output of the system is required, the emphasis can be set on power. Now, some broadband control might be sacrificed in favor of system headroom. The realizer bar constantly indicates how well the current settings can be achieved. A red indication here will not allow the optimization process to be initiated. If the meter is green or yellow, the calculation can be started. When the optimization process has finished, the respective filter settings are stored in the selected slot. The Result tab then shows the processed and unprocessed frequency responses for a selection of reference points. At this point, it is highly recommended to assign a meaningful name to the slot, as well as a further comment if required. This information will also be visible in the R1 remote control software. The level over distance plot on the Sources tab now also displays the processed results. Before the project can be saved, the amplifiers have to be configured. The project file is then saved in the new DBAC2 file format, which can be opened directly in R1.